Now, to get our partial derivatives, we can do the partial derivative of your total cost with respect to Q and with respect to S. Again, it will be easier for us to get the partial derivative of S first, with S first. So let us do that. Partial derivative of your total cost with respect to S is equal to, this is 0, 0. For this one, you bring down 2. 2 will cancel with 2 here. So in the end, you will get an H S B minus A all over B Q. Next, for this component, we will also bring down 2, but because of the chain rule, we multiply by -1. So this becomes a minus P Q minus S times B minus A over BQ again. And then you equate this to 0. Upon equating this to 0, we can technically get rid of our denominator, and we will end up with an HS B minus A minus P Q minus S B minus A equals 0. We can factor out B minus A, and we will end up with an HS minus a PQ, no, plus PS equals 0. We cancel B minus A, and we will end up with an S quantity P plus H, this plus this, no? And then minus PQ will be transferred or transposed to the right. So this is equal to PQ. And in the end, we will get an S is equal to P over P plus H over times Q. Surprisingly, we also were able to get the same value for S in terms of Q in model number 2. Okay? Now, for the derivative with respect to Q, it will be very tedious because the first term will be easy because that's just negative AK over Q squared. The second term will just be 0. The third term will also be easy because this is just a minus HS squared B minus A over 2BQ squared. However, the derivative of this part will be very hard because we will again use the quotient rule. I will just refer you to my notes on the derivative of this component, but in the end, what we will be able to get is a Q star, which is equal to square root of 2AK over H square root of P plus H over P square root of B over B minus A. Now, I want to give you a summary of all the Q stars or the optimal order quantity Q for all the 4 models that we were able to model and formulate. Okay? And to start with, let me start with model number 4. Your Q4 star, or the optimal order quantity of model number 4, is equal to square root of 2AK over H, square root of P plus H over P, square root of B over B minus A. Now, what I'd like you to do is to look at the limit of this Q4 star as P approaches infinity. And when we are getting the limit as P approaches infinity, try to understand what we are actually doing. In the first place, what is P? P is the shortage cost. So what are we trying to do when we are trying to get the limit as P approaches infinity, or as P becomes a very, very big number. So imagine your shortage cost to be a very, very, very big number. What happens to this equation? The limit of Q4 star as P approaches infinity becomes this. Why? Because of the L'Hopital's rule. Remember, if your limit as P approaches infinity makes your equation infinity over infinity, all you have to do is get the derivative separately, the derivative of the top and the derivative of the bottom, which will give us a 1 over 1, which gives us the square root of 1, which eventually is just equal to 1. Therefore, what we will end up with is square root of 2ak over h times square root of b over b minus a, which surprisingly is model number 3. Why? Because if you look at the difference between model number 4 and model number 3, model number 4 just assumes that there is shortage, or you are allowing shortage. On the other hand, model number 3 assumes that there are no shortages allowed. And in this case, by saying that the shortage cost approaches infinity, it is the same as saying you are not allowing shortages. In the same way, if we get the limit as b approaches infinity of your Q4 star, what do we get? Again, using L'Hopital's rule, this becomes 1 over 1. This entire thing becomes 1, and therefore this is equal to square root of 2ak over h, square root of p plus h over p. Again, surprisingly, this is model number 2. If you look at model number 4 and compare it with model number 2, the difference really is in the supply rate. Both models, model 2 and 4, will allow shortages, but model number 2 assumes that your supply is instantaneous. And what do we mean by that? That means that no matter how big your order is, your supplier will be able to deliver everything all at the same time, which mathematically means you are letting B, the supply rate, approach infinity. And finally, if you try to get the limit, the double limit of Q4 star as B approaches infinity and P approaches infinity, it won't be a surprise anymore that this is equal to square root of 2ak over h, which is model number 1. Because if you don't allow shortages and you assume that supplier rate is instantaneous, therefore you get the assumptions of model number 1.